Welcome to this module. What we are discussing in this module is very interesting. We want to understand different signals starting from Ecg. We want to understand what kind of biopotentials are there, particularly when we talk about Ecg, we talk about Emg, we talk about Eeg, and then we will be focusing on what are the fundamentals of Eeg and how can we design a signal conditioning circuit to acquire the Eeg signal. Okay. So, we will also see details on how can you design a circuit and how can you understand different signals coming out of the Eeg, how can you do the signal conditioning of those signals. In the experiment part, one of my TAs will show it to you how the dry electrode looks like and what exactly are the advantages of dry electrode over wet electrode. So, I will come to that point. Before that, let us see what are the biopotentials that we can that we generally measure, right, from the human body. To start, we will talk about Ecg. Ecg stands for electrocardiogram, and as most of us knows, if you see or if fan of movies, you always see, in fact in the serials also you will see that there is a Ecg measurement in the hospital, right. Whenever somebody has a heart problem, we need to record the Ecg signals, and that is why Ecgs are mostly used for understanding the heart activity. Same thing goes for muscle movement. When we want to understand how the signals are generating when we are moving our muscles, there is a name for that which is called Emg, and it stands for Electromyogram. Same thing when we have to understand our eye movement, how we are blinking our eyes and what kind of signals are generating from that blinking of the eyes, then we can have electrooculogram. And finally, when we are understanding the brain waves and the signals coming out of our brain, we rely on Eeg, which stands for electroencephalogram, where we can understand lot of things including seizures, including epilepsy and dyslexia. So, lot of problems we can understand if we know how to analyze Eeg signal. Okay. Right now, what we are interested is to develop a system that can be used for measuring Eeg in particular. Our focus is more on developing a system which can measure Eeg. Finally, there is another biopotential which generates from the skin, and that is a resistance, is called galvanic skin response, and the things are measured generally with the electrodes with the use of skin electrode interface, and because of the exchange of ions between electrodes. Same thing we can also understand breathing, temperature, movement, etc. We can also measure this thing with other sensors or transducers. To name a few, we have piezoelectric crystal, we have Hall sensors, accelerometers, we have LDR, etc. So, I will start with the Ecg, and we will not discuss too much detail about Ecg. I will just quickly run the slide through because we have to concentrate more on Eeg. So, when you talk about Ecg in particular, you generally see this kind of waveform, right, and generally we had interested in QRS waveforms, and but to understand the complete to understand the functioning of the heart, we generally see at PQ and QRS signal. So, again when you go in detail, it is a systolic and diastolic pressure that you have to understand, and when a opening of heart and closing of heart, the valves in the heart causes the change in the electrical signal, that resists the Ecg that you can see here. Mostly what we are interested is in PQ signals and QRS signals. So, QRS complex is where the important physiology lies, and this is how the vector is formed. There are ways of measuring the Ecg signals, and some of the ways of how to connect the Ecg electrode is shown in this particular video. So, I will play the video for you, and then we will continue with the measurement. Okay. So, let me play the video for you.
Fast and accurate 12-lead ECGs with Tim Phelan.
Oh, hi. All right now. It came in as a 45-year-old male complaining of some heartburn, maybe some chest pain. Wife says he started to feel a little sicker. Anything from indigestion to infarction or a lot of things in between. But you know, this is and I'm doing it, so it's a pretty safe bet. This poor guy is going to be having an acute myocardial infarction. Why don't you come along with us and we'll show you how to do a 12 lead EKG. You ready? Let's go.
Tim Phelan is a seasoned paramedic with more than 18 years in EMS. An internationally known author and educator, he has trained more than 25,000 paramedics and nurses on diagnostic 12-lead ECGs.
Thanks for the nice intro. You know, the American Heart Association, in Chapter 9 of their new textbook, talks about the acute coronary syndromes, including myocardial infarction. And it makes some pretty bold statements. It says that emergency care providers, that's you and I, need to be familiar with the core principles of diagnosis and treatment of these acute coronary syndromes. It also says that the 12-lead ECG stands at the center of decision-making for these acute coronary syndromes. Okay?
12-lead ECG is a routine part of the assessment of a patient with possible ACS. Included with the history, symptoms, and vital signs, the 12-lead ECG is critical to the diagnosis and treatment of the cardiac patient.
A little chest pain, is that right? No. Tell me again what you were doing when the pain started.
Explain the procedure and reassure the patient. Remove the clothing on the upper body. Wipe the electrode sites with a brisk dry rub. Oily, dirty, or diaphoretic skin should be quickly cleaned with an alcohol wipe.
This is all really routine, standard stuff.
Allow the skin to dry before placing the electrodes. If necessary, shave or clip hair on electrode sites.
There you go.
The ECG is best obtained with the patient resting in a supine position, lying as still as possible for the 10 to 15 seconds required for the ECG device to acquire all of the information. The patient must be relaxed, warm, and as comfortable as possible, with all limbs supported. If the patient is uncomfortable or having difficulty lying flat, place him in a low-sitting position and make a note on the ECG printout.
Well, you get the basic idea. But I would like to take a minute to go over a couple of key points. First, scene time. Studies and experience have shown that getting a 12-lead ECG does not prolong scene time, so don't be concerned about that. Second thing, getting a 12-lead really is pretty easy. Once you've done a few of these, you'll see for yourself. The truth is, the skills you've learned already are far more difficult than 12-lead acquisition. And remember, getting a 12-lead makes a difference on scene, en route, and arrival at the hospital. Of course, to be valid, it absolutely has to be done correctly. So, let's talk about ECG monitoring in general. Everyone is familiar with leads 1, 2, and 3. You learned about them in school, you've been using them for years on your job. And when you've used them, you did it for the purpose of identifying cardiac rate and rhythm. Now, each one of those leads is a view of the heart. Each one of those 3 leads has a single positive, a single negative electrode, and a ground. The actual view of the heart is seen from the positive electrode toward the negative electrode. That's why each of the complexes have a slightly different configuration. The ground electrode helps to reduce electrical interference and helps produce a clear tracing. To get a 12-lead ECG, we must isolate only the heart's electrical signal.
The human body and external environment have many sources of electrical signals. The electrocardiograph can detect and reproduce the various electrical signals of cardiac conduction. The monitoring frequency response mode provides a 0.5 to 40 Hz view of cardiac conduction, while the diagnostic frequency response mode provides a 0.05 to 150 Hz window. This broader frequency bandwidth accurately reproduces cardiac electrical data necessary for diagnostic interpretation of the status of the myocardial muscle, which may be reflected in the ST segment of the cardiac ECG complex. The ST segment is found in the lower end of this electrical frequency window. An accelerated rate of play is assumed as the eligible receiver runs a complicated pattern downfield. The two backs protect the center in a lane and at angles easy. The elevation of the plane is...
Whoa! Time out. That's the textbook version of frequency response. Here's the real-world version. You see, the difference between 3-lead monitoring and 12-lead monitoring is not the number of wires coming out of the machine. The difference is frequency response. In monitor quality, the machine is not attempting to reproduce the full spectrum of cardiac electrical activity. Instead, it's just focusing in on the center portion, so it can see the QRS complex, so you can do rate and rhythm. In the process, it's filtering out some artifact which makes the ECG clear. That's terrific. But you cannot do this for ST segment analysis because in monitor quality, you can't see the ST segment properly. That's why the 12 lead has to be done in diagnostic quality. In diagnostic quality, the machine is able to see the full spectrum of cardiac electrical activity. Not only the QRS complex, but the ST segment as well. You notice that the artifact is seen a little more clearly as well, but because we need to see the ST segment, all 12 leads must be done in diagnostic quality.
The 12 views of the heart are taken with 10 electrodes. The 4 limb lead electrodes do not require precise anatomical placement. However, it is best to avoid sites that have a lot of hair, large muscles, or bony prominences. The upper limb electrodes can be attached anywhere along the arms, from the wrist to shoulders, as long as they are off of the torso. The lower limb electrodes may be attached anywhere from the ankles to the thighs. The 4 limb electrodes provide a total of 6 leads, leads 1, 2, 3, AVR, AVL, and AVF. All limb leads provide a view on the vertical or frontal plane of the body. The 12-lead ECG adds 6 views through electrodes placed on specific points on the chest wall. These chest leads, also called precordial or V leads, provide a view on the horizontal plane of the heart.
The international standard for 12 lead placement requires that the limb leads be positioned on the limbs and not the torso. In reality, however, some emergency departments obtain the limb leads from the patient's torso. In that case, you may opt to do the same for the sake of consistency. So, while there may be some variation in limb lead placement, there can be no variation in chest lead placement. The chest lead electrodes must be obtained from their specific anatomic landmarks. Let me show you. Find the clavicle and position your finger just below it. Move your finger until it contacts the sternal border. You're in the first intercostal. Find the second, third, and fourth intercostal space. Position the electrode for V1 just to the right of the sternum in the fourth intercostal space. V2 goes in the corresponding intercostal to the left of the sternum. Skip V3 for the moment. V4 goes in the mid-clavicular line, fifth intercostal space. V3 is positioned between V2 and V4. The V5 electrode is horizontally level with V4 in the anterior axillary line. V6 also horizontally level with V4 in the mid-axillary line. Notice we did the 12-lead ECG on the scene. This was very intentional. For a variety of reasons, the ECG may change quickly, and the early tracing may provide very valuable information. Let's take a look at some tracings. The first shows gross and obvious changes. The second tracing was obtained from the same patient only a few minutes later, and the changes have all but disappeared. That's why it's important to get the first ECG with the initial set of vital signs. Get a repeat ECG every 5 to 10 minutes, or at least with each change in patient condition.
Okay. So, you have seen in the video how the ECG electrodes can be placed and how we can get the signals from the ECG electrodes. Now, let us, like I said, our focus is more on EEG. So, I am just running through slide so that you can have you understand that if I can design a signal conditioning module for EEG, we can also design signal conditioning module for ECG as well and EMG as well and other biopotentials. So, if I consider the applications, or if I look at the applications of ECG, the applications of ECG are in diagnostics. We want to understand the heart rate, the health of heart. We also need it for functional analysis. Sometimes when you implant the pacemaker, then we need to understand how the ECG signals are behaving. We also want to understand, if you want to understand the heart rate variability, then we require ECG signals. Again, we want to understand peak performance training and monitoring, we again require the ECG. So, the applications of ECG are enormous, and we have to rely on ECG signals right now for understanding the health of a heart. So, let us move to the next way of understanding the signals, and that is from the muscles. So, as you see here, right, these electrodes are placed with the help of glue. See, the reason of using glue is to reduce the impedance. Now, when you relax it and when you expand it, you can see the change in the EMG signal. EMG signals are close to 3 millivolts at 1 kilohertz, and you can see the change in the signals when it is relaxed compared to when it is expanded, right. So, again this is another way of measuring the muscle movement, and people have used this particular signals to help move the arm of a patient who has lost his motor skills. So, let me show you, let me show you in my hand what exactly I mean by motor skills. Okay. So, motor skills, when I say is let us say if I say fold your hair, fold your palm, this is what I am doing, right. So, to make a fist, right. So, when the signals are sent from the brain to my hand to fold it to make a fist, right, then this is the motor skills. Same way to hold a pen, right, same way to hold a mobile, right. So, or to wave at you. So, this all movements are because of the synchronization between the signals that is sent to you from your brain to your muscles to operate. Now, if somebody has lost a motor skill, that means that either a part of that or hand or the other part of the body, it is not working as the signals are not getting translated to that particular organ, right. So, how to use EMG signals to control the muscle movement of a person who has lost motor skills. So, people are doing research on that. How can you understand this and how can you control it? First thing is you need to understand what are the signals coming from your muscles. When I move my muscles, right, this movement of muscles causes the change in the or generates the signal, and this signal was as you can see or as we have seen is about 3 millivolt at 1 kilohertz frequency. Now, what kind of EMG electrodes are there, that we will see, and like I said again I am reiterating it that we are more focused on EEG in this particular module and not ECG and EMG, but I am just giving you an idea that if you know EEG you can also understand ECG, you can also understand EMG. So, if you see the slide, this is how the EMG passive electrodes looks like, where it takes the signal from the muscle movement, while there are other electrodes called EMG active electrodes. There is a company called Myoscan which sells this active electrodes for measuring the EMG signals. Let me play the video for you, so you understand how exactly the EMG electrodes are placed.
NCV EMG derivations comprise a multitude of investigatory measurements as well as their electrodes and accessories. GVB Limit will supply you with the electrodes required for stimulation and derivation, including the appropriate accessories ranging from cable connectors through pastes and creams. These will be of optimum quality, permitting you to carry out derivations with no complications and to receive stable results. Now you see a standard NCV EMG investigation using different stimulation and derivation measurements, as well as a special form of neurography, the blink reflex. Prior to the neurographic investigation, a ground electrode is placed over the wrist between the recording electrode that has yet to be positioned and the stimulation area. Finally, this is connected to the EMG instrument by a snap cable. In motor neurography, the recording and stimulation areas should be decreased before the recording electrodes are attached. Following this and using the belly tendon technique, the active electrode should be positioned on the muscle belly and the reference electrode above the attachment of the tendon. In this case, tap adhesive electrodes with crocodile clip lead wires are used and connected to the EMG instrument using a multifunctional cable. Various types of multifunctional system electrodes can be connected to this multifunctional cable. However, snap cables that fit the multifunctional system and snap adhesive electrodes can be used as an alternative to the crocodile clip cables and tap electrodes. Waffle electrodes are a further alternative. However, electrode gel should be applied prior to use to guarantee a good electrode resistance. The electrode itself is attached using adhesive tape. Plate electrodes that are employed in the same way, and disc electrodes that also have electrode gel applied to them and are fixed using adhesive tape, form part of the multifunctional system electrode program and can be used as alternatives. The stimulation electrode should be ready prepared for use. For this, sweep the stimulation balls into the electrode appliance. If you are using stimulation electrodes with felts, soak these in NaCl liquid prior to inserting them into the appliance in order to guarantee good skin contact and a good resistance too. However, the felt must be dried well to avoid wetting the skin. The next step is the connection of the stimulation electrode to the EMG instrument. The stimulation electrode is placed over the nerve and the stimulus is increased following a predetermined sequence until maximum amplitude is reached. The user observes motor reaction as a control. The stimulus is increased until a supra-maximum stimulation is attained, recognizable by the fact that there is no further increase in amplitude. The cursor is set exactly to the initial negative potential output. The highest and lowest points in the curve determine the amplitude's magnitude. The electrodes must also be moistened with NaCl when stimulating with finger-toe stimulation electrodes. However, the electrodes should not be wet. Therefore, dry the electrodes with a cloth. A ground electrode is also placed over the wrist between the stimulation electrode and the stimulation area prior to connection the EMG instrument when using stimulation in sensitive neurography with finger-toe stimulation electrodes. First, the cathode is attached proximally to the finger base joint and the anode is then attached distally to the fingertip. There should be no liquid bridge between the two loops, which can, however, be ensured by prior drying to the electrodes. Finger-toe stimulation electrodes are also a part of the multifunctional system and can now be connected to the EMG instrument by the multifunctional cable. The sensitive recording electrode is positioned directly over the nerve above the wrist, attached using Velcro tape, and then connected to the EMG instrument. This stimulation and recording electrode has already been used as a stimulation electrode in the previous section. The Autotrol method shows the first variations of sensitive neurography. During stimulation with this method, stimulation is carried out supramaximally, an example until the amplitude increases no further. This is similar to the approach taken in motor stimulation. Then the signal is averaged online. A sensitive nerve action, potential-free of noise, is obtained after averaging approximately 20 to 50 times. The antidrome method shows the second variation of sensitive neurography. In this case, digital ring electrodes are used as recording electrodes. The active electrode is attached proximally and the reference electrode attached distally in this method. These electrodes that are also parts of the multifunctional system can be connected to the EMG instrument by the multifunctional cable. Contact gel must be applied to the contact surfaces on the metal loops once the ring electrodes have been connected to the EMG instrument. This guarantees an optimum contact resistance. In antidrome sensitive neurography, recording occurs from the skin and the respective peripheral nerve is stimulated. Antidrome stimulation is advantageous as it is a rapid method with a high response amplitude. However, motor overlaps can have an effect on this method. Our Myoline needle program supplies EMG needle electrodes of different lengths and diameters for the pain-free investigation of superficial muscles, deep muscles, and also small hand and fascialis supplied muscles. These needles can also be connected to the EMG instrument using the multifunctional cable. Specialized forms of neurography like the F-wave, or as shown in our example, the blink reflex, can be applied extremely well using disposable adhesive electrodes or disposable adhesive snap electrodes. The respective reference electrode are attached above the nasal wings, and the active electrodes are attached above the respective orbicularis oculi. These electrodes can then be connected to the EMG instrument using the multifunctional cable. To prevent an ACL liquid from being released from the felts and running into the eye. For the stimulation, it was used a stimulation electrode with stimulation balls. The blink reflex can thereby be derived free of add effects. Several curves must be overlaid, and the R1 and R2 components on the stimulatory side and the R2 component on the contralateral side are determined. Alternatively, disposable adhesive electrodes can be used. In this case, a ground electrode is first placed on point N and then connected to the EMG instrument. The adhesive electrodes are then attached to the respective orbicularis oculi as done previously with the reference electrodes and subsequently connected to the EMG instrument with 1.5 mm safety connectors. To prevent liquid spills, a stimulation electrode with stimulation balls is also used in this blink reflex recording. GVB in cooperation with Beth Medica always wants to offer you all stimulation electrodes and accessories which suffice the newest technical requests. GVB electrodes enable stable and comfortable recordings for you and the patient. If you need further information to find the right electrodes or accessories for your request, please call us. The team of GVB will be happy to answer your call.
Okay, so you have seen the video, right? Now, if I talk about the applications of EMG. So, what are the different applications of EMG? So, if you see the screen, the EMG applications can be in rehabilitation, right, rehabilitation. Like I was telling you, there is a company Myoscan. You can see the EMG sensor over here, there is a goniometer over here, while there is a force transducer over here. This also helps to understand how the functional analysis is done. It is also used in sports medicine. It is also used in active prosthetics. It can also be used for rehabilitation, like what I already said. And same thing you see here, that for movement of the eyelids, right, you can see here lateral frontals, medial frontals, right, depressor, supercilii, levator labelli, orbicularis oris inferior, as well as the mentalis. Everything that we have on our face, right, when we ever move the muscles, that muscle movement will cause change in the voltage, and that voltage is nothing but we can measure with the help of EMG, alright, which is called electromyogram.